Alright, so today we're going to go over a skill that you need in order to compare linear functions in Module 6, and that's writing functions from tables by solving for the missing y-intercept. So we're starting on the front with a table, and we've learned in the past the y-intercept is the value of y when x is equal to 0. And in this table, we don't have 0 given as an x value. We have learned that you could skip count backwards, but that's not always feasible. You can do it in this table, but I'm going to show you another way of doing it down below. So we're going to start off with finding the slope using the slope formula, which is y2 minus y1 over x2 minus x1. And then I'm just going to pick 2 points from the table. I'll just choose the 2 in the middle. And I'm going to start by writing those as ordered pairs. And then labeling them x1, y1, x2, y2. Now I know exactly where to put them in my formula. So I'm going to put y2 as 6. Remember to always write the subtraction sign, even if your second number is negative. And then y1 is 4.5 over x2 is 4 and x1 is 3. And now I'm going to simplify. So 6 minus 4.5 is 1.5, and 4 minus 3 is 1. So this is 1.5 over 1, which just means that our slope is equal to 1.5. And we label the slope with the letter m. Okay? Step 2 is going to be to find our y-intercept, and we're going to do that by plugging in the slope that we just found and a point from our table into slope-intercept form and solving for the missing value of b, which is the y-intercept. So the slope is here, and that is m is equal to 1.5. I also need a point. I'm just going to pick any of these. It doesn't matter which. I'll pick the first one, 2, 3. And I'm going to label these x and y. Now I'm going to write my formula, which is y equals mx plus b. And I'm going to replace 3 out of these 4 variables with the values that I already know. So I know if I'm starting with y, I know y is going to be 3. It doesn't have to be 3, but that's the point that I chose. You want to make sure that you're putting in the y value of the point that you chose. So I'm going to replace the y with 3, which is coming from the point that I chose. And then m is equal to 1.5. I found that in my previous step. And I'm going to use parentheses here because m is multiplied by x. So I want to show these as multiplication. So I'm replacing m with 1.5, and I'm replacing x with 2. And then I'm solving for b. I don't know what b is. That's the whole point of doing this step, so I'm not going to replace b with anything. Now I'm going to multiply 1.5 times 2, which gives me 3. I'm dropping down this 3 as well for my value of y, my equal sign, and plus b. And now if I look what I add to 3 to make it equal 3, this has to be 0, and I can show that using inverse operations as well. So b in this example equals 0. Okay, and I'm going to rewrite that up here just to be a little bit neater. And now that I have my value of m and my value of b, I can write my final equation in slope-intercept form. So that would be y equals mx plus b, where I replace the slope and the y-intercept. I leave x and y in my formula because there can be multiple points on a line. Okay, so this is going to be y equals, my value of m is 1.5, x plus my value of b is 0. Now I don't have to write plus 0, so I'm going to rewrite this one more time as just y equals 1.5x. Since this example has a constant rate of change and the y-intercept is 0, this means it passes through the origin. So I know that this example is a linear proportional function. Okay, so let's flip forward and look at another example. Once again, write an equation in slope-intercept form to represent each table below. So now I'm going to go through that same process where first I'm going to pick 2 points from my table to find the slope from. I'll just pick the first 2. I'm going to write them as ordered pairs. Oops, I started with the second one. That doesn't matter. And now I'm going to label them x1, y1, x2, y2. And I'm going to plug them into my formula. So y2 minus y1, I always subtract my y values on the top. I find the change in y. So that's going to look like something minus something, y2 minus y1, 20 minus 25. And on the bottom, the difference in my x values. So x2, 100 minus x1, 200. Now the way that I wrote this, I started with the second point for some reason. I'm going to end up with negative values here. 20 minus 25 is negative 5, and 100 minus 200 is negative 100. But that's okay, as long as you're starting with the same point. Like I started with the 20 on top, so I started with the 100 on the bottom. You'll still get the right answer because this is a negative value divided by a negative value, which results in a positive value. I can also simplify by dividing both of these numbers by 5, which leaves me with 1 on the top and 20 on the bottom. And this is a positive value, again, because negative divided by a negative is a positive. Okay, I could also write this as 0.05, so if you wanted to write it in decimal format, you could. Next, I'm going to plug in my slope and a point into slope-intercept form to solve for my missing y-intercept. I don't have the value of y when x is 0, so I need to solve for that. So m is equal to 1/20. And then I'm going to pick a point. I can pick one of the points I used in finding the slope, so I'll just pick the first one again, 100, 20. And I'm going to label this x and y. And now I'm going to plug those numbers in to y equals mx plus b. I'm replacing y with 20, m with 1/20, or 0.05, x with 100, and I don't know B yet. Now I need to multiply the value of m times the value of x, so 100 times 1/20th. I know that when I multiply a whole number by a fraction, I multiply it by the top and then divide by the bottom. So 100 times 1 is 100, divided by 20 is 5. So this equals 5. And I'm going to drop down 20 equals and plus b. And now what is added to 5 to get to 20? Well, that must be 15. I'm going to show that with inverse operations. And now I have my y-intercept. Last step is to put both of these things together into slope-intercept form, which would be y equals 1/20th x plus 15. This is an example of a function that's linear. It has a constant rate of change, but it's not proportional. It does not start at the origin. All right, let's do that one last time. So picking 2 points, I'm going to pick the ones on the very end this time. 11 and 58 and 14 and 55, just to show you it does not matter. x1, y1, x2, y2. Starting with change in y on the top, 55 minus 58, and change in x on the bottom, 14 minus 11. Notice I'm not starting with the bigger number each time, I'm starting with the same point, y2 minus y1, x2 minus x1. 55 minus 58 is negative 3, and 14 minus 11 is positive 3. And negative 3 divided by positive 3 is negative 1. So my slope is negative 1. And I can tell because that it's a negative rate of change because as the x values increase on this one, the y values are going down. That's the first example we've seen today of that. So that's why my slope is negative. So coming down here, I know my slope is now negative 1. I'm going to choose another point. Let's choose 861. Label it with x and y. And write slope-intercept form where I'm going to plug in my value of y, m, and x to solve for b. So y is 61. M is negative 1. Just go ahead and fill in my blanks here. M is negative 1. X is 8. And I don't know B. Negative 1 times 8 leaves me with negative 8. Drop down 61. And now to figure out what B is, I can use opposite operations again to cancel out minus 8. I'm going to add 8 this time because I want to make 0. I'm going to add 8 to this side, and I can see that B is equal to 69. Now I plug those numbers into slope-intercept form for my final equation, which is y equals negative 1x. I don't have to write the 1, so I'm just going to write negative x plus 69. Once again, this is linear. It's decreasing because the slope is negative, and it is not proportional. It starts at 69. All right, let's bring this concept into a real-world problem to finish off. Pilar is climbing down a canyon wall. Climbing down is going to be a key term there. We're going down. His height per minute from the ground is shown in the table. This is his rate of change, right? Write an equation to represent the situation and determine how long it'll take for Pilar to reach the ground. Okay, so first we want to find that rate of change, Pilar's height per minute, so we're going to find the slope. This is the same way we've started all of the other problems. I'm going to pick 2 points. I'm going to write them as ordered pairs. I'm going to label them and plug them in to my slope formula. Change in y over change in x. So on the top, 226 is my y2, 234 is y1, 2 is x2, and 1 is x1. When I subtract 226 minus 234, I get -8 over +1. So this means when I want to write it as a rate, that means I want to use the words from the problem. So these y values represent feet, and the x values represents minutes. So Pilar is going down the canyon wall at a rate of -8 feet per minute. This is my slope. Next, I want to find the initial value. So that's where Pilar starts out on the canyon wall, how high above the ground he actually is. And once again, I'm going to do the same thing. I'm going to pick another point. Could be one of the points I already used or not. And I'm going to use the slope that I just found, -8. That point that I chose, which is 3 to 18. And I'm going to plug that into slope-intercept form. Y equals mx plus b. So my y value that I chose is 218. I'm going to fill in my slope, my x value, and I'm going to find b. My slope is -8, my x value is 3, and now I can simplify this to find b. So -8 times 3 is -24. To find out what b is, I'm going to cancel out this -24 by adding 24 to both sides of my equation. I'm going to move up here because I'm out of room. 218 plus 24 leaves me with 242, which is going to equal b, which means that Pilar's initial value is 242 feet above ground. So Pilar begins 242 feet above ground. And our last question is going to have us use our equation that we can create with these values to answer how long it will take Pilar to reach the ground. So remember, our height off the ground are our y values. And if Pilar's on the ground, there is no value for the height, right? He would be at 0 feet above the ground. So we want to find out what is the value of x, how long does it take Pilar to get to the ground, to get for these numbers to reach 0. okay? And we can use an equation to do that. So my equation in slope-intercept form is y equals -8, that's my slope, x, -8 feet per minute, plus the initial starting height of 242 feet. Now, I want to know, when is the height 0? Right? When is the height 0? And we can solve this like a regular two-step equation by subtracting 242. And then dividing by -8. Some of you might have already thought to yourself, oh, take the entire height that Pilar needs to descend from and divide it by the rate. That's exactly what we're doing here. It's just showing how you can use the equation to do that. Which we get 30.25 minutes.